Hello, ladies and gentlemen. Welcome back. Today we're going to be talking about organic compounds again. We finished our lecture last time, and you read an article about what organic compounds are, and then we practiced writing out some of the structural formulas and skeletal formulas. So today, let's just take a quick look, and we'll look at propane just to give us a review. The molecular formula of propane is C2. Whoops. Is C2H6, okay? Which means there's 2 carbons and 6 hydrogens. It's also known as a hydrocarbon. Hydro meaning hydrogen and carbon being carbons, all right? So that's what an organic compound is. It's a compound made up of carbons. Now, we're going to take a look at the 4 different ways that we can depict or draw out propane. Number 1 is the Lewis structure. Now we practiced the Lewis structure in Unit 5, and you remember the dots were the electrons, and we had to calculate how to draw this out. And then we have changed that into a structural formula where you can see that wherever those dots are between 2 elements, that became a bond, and so we were able to make this structure. And then we're turning this into a line diagram where each one of the points on this line diagram represents a carbon with those 3 oxygens, or with the hydrogens attached. And finally, we have the condensed formula. All of these are the same, okay? So you can see that there's 3 hydrogens on this side, and we have CH3 with the 3 hydrogens on that side. And we'll take a look. You can see this one. There are the carbon with the 3 hydrogens, and again, the carbon with the 3 hydrogens. And finally, you can take a look and you can see the carbon with 2 hydrogens in the middle, all bonded up, the carbon with 2 hydrogens in the middle. And since all of these represent the exact same thing, we can take a look and we can see that this carbon right here would be the carbon, because we said there's a carbon at each point. That would be a carbon with 3 hydrogens attached. But remember, we don't show the hydrogens. And this center carbon has 2 hydrogens attached. This one here. So there's a carbon at that point, and there would be 2 hydrogens attached. And finally, this last carbon over here, there'll be a carbon at that point, and there'll be 3 hydrogens attached. But remember, we don't show the hydrogens when we're drawing out the line diagram or the skeletal formula, which is how I'm describing it, because it's just the bones of what we're talking about. But you can see how all of these are related. This one here and this one here are 2 of the best ways to draw it. This one is the easiest, and it's the simplest. It allows us to see the general idea or the general makeup of our compound. And this one here shows what's connected to what as we go and look at our compounds. So what we're going to do today is we're going to start working backwards from what we did last class. So last class, we learned how to draw out this skeletal formula or this skeletal diagram. And today we're going to work backwards and go from our skeletal diagram to make a molecular formula and a condensed formula. And very quickly, again, remember the molecular formula is just this one right here. It's just the standard, how many carbons, how many hydrogens. Then the condensed formula shows us how the compound is organized, okay, without drawing all the bonds and all the electrons. So let's start off by just taking a look. Now, remember that we have a carbon on each point of this. So we have a carbon here. Whoops. We have a carbon here. Here's a carbon. Here's a carbon. Now, there's no carbon out here. There's actually a bromine. So this is only a 3-carbon compound. Now, there's some tricks that we learned. Remember, we learned that all compounds want to have an octet. An octet means 8 electrons in its valence. Well, carbon is the same. So there were bonds. So when things are bonded together, each bond is made up of 2 electrons. For example, carbon, if you're going to just bond it here, you can see that this carbon will be bonded to 4 hydrogens. Why 4? Because 2, 4, 6, 8. Each bond has 2 electrons, which means that carbon, shortcut idea, is always going to have 4 bonds. And that's what's so great about carbon. Well, so we want to take a look at this octet rule and use it to help solve for how many of everything we have on this compound. So what do we have? Well, we can see right away we have 1 bromine on this compound. And how many carbons do we have? We have 3 carbons. And now the most difficult part is trying to figure out how many hydrogens do we have? Well, you know that each carbon needs to have 4 bonds connected to it. So this carbon is an end carbon, which means that this carbon needs 4 bonds total, right? It needs 4 bonds total. One of those bonds is made up of a a carbon. So I'm going to use this as my my little helper today. Okay, so I'm going to just continually refer to this one here. So this will be this carbon here for now. One of these is bonded to another carbon. So this carbon's bonded to another carbon, which leaves how many hydrogens for us? Well, there are going to be 3 hydrogens bonded here. Why? Because each carbon needs 4 bonds, and we're trying to find out we're trying to find out how many hydrogens do we have for this compound. Now, this carbon has 2 bonds already attached, 2 carbons, and it doesn't matter where we put them. So this middle carbon here has 2 carbons attached, leaving us with how many bonds do we need? Well, with 2 more. So we're going to have 2 hydrogens out here, right? This carbon here, if you take a look, is bonded to what? It's bonded to a carbon, and it's also bonded to a Br. So there's its Br. So what's that leave? Well, if there's 1 bonded to another carbon, and there's a 1 bond to a bromine, that's going to leave 2 spots for our hydrogens. And so on this one, we're going to have 2 hydrogens coming in. Now, since our whole purpose is to find out how much of everything we need, because we want to find the molecular and the condensed formula, you can see we need 3 hydrogens, 4, 5, 6, 7. So we need 7 hydrogens. And now we have our molecular formula. We always are going to put carbon first, followed by hydrogen, and then by whatever else is left over. So how many carbons do we have? 3 carbons, 7 hydrogens, and the 1 bromine. So this would be the molecular formula. Now, what would be another way to write this out? Well, we want to use the condensed formula. So this would be the molecular formula. And now the condensed formula. Well, you can see that we're going to start off with a CH3. That's going to be followed by a CH2, which is then going to be followed by another CH2. And there's a Br attached, so it's going to be CH2 Br. And all of these things right here are attached to that carbon. Basically, whatever's following that carbon is going to be attached to it. All right? And so that would be our 2 answers. It would be our molecular formula and our condensed formula. This is a better way to draw things out. If you don't do the skeletal formula, which is just awesome, then this is the best way to draw it out because you can see how things are connected together. All right, so we'll be using the condensed formula whenever possible. And that's it. So let's take a look. Let's move on to our next compound, all right, that we're going to do. And we're going to be working on the same thing. We're going to be working with a molecular formula and condensed formula. All right, so let's take a look at number 2. All right, so number 2. Let's start off. Well, what do we have, ladies and gentlemen? First, we're going to analyze our skeletal structure. So when I take a quick look, ladies and gentlemen, at this structure, the first thing I do is I say, okay, is there anything on here besides carbons and hydrogens? No, there's not. There's only carbons and hydrogens, otherwise it would be labeled. So where would the carbons be? They're going to be all of the corners and all of the endpoints. So there's going to be a carbon here. There's going to be a carbon here. maybe another carbon, and finally a last carbon. So this would be all the locations where the carbons would be. How many would that be? 1, 2, 3, 4, 5. So we can just take a quick look. So our carbons, we're going to have 5 carbons. And now we want to figure out how many of everything else we need. Now remember, how many bonds will each carbon need? How many bonds for each carbon? That's right, there's 4 bonds. If we take a look at this first carbon, right, then this carbon already has 2 bonds to a second carbon, which means that this carbon's going to need 2 bonds. Since they need 4, this would be 1, 2, 3, 4, because this would be the third and the fourth bond. And then this carbon, if we take a look, this carbon has 1, 2, 3 bonds, which means there's only room for 1 more. So this carbon only has 1 hydrogen attached to it. Now let's come to the next carbon. We'll call this carbon number 3. We'll call that carbon 2 and carbon 1. All right. So this carbon has 1, 2, 3 carbons attached to it, 3 bonds, which means how many more bonds does this carbon need? Good. This carbon's going to need 1 more bond. So I can just, I won't put it there. I'll put it over here. It's usually where we put it. Okay. There's 1 there. If we come up to this carbon, that might be number 3. We'll call this one carbon 4. This carbon has only 1 attached. It wants to have a total of 4. So there'd be 1, 2, 3 hydrogens. Now, if you're going, okay, we're done. Nope. Got to get to this 5th carbon. This carbon only has 1 bond. It needs a total of 4 so it can reach its octet. And now we have the total number of hydrogens. So we can count up our total number of hydrogens now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to have 10 hydrogens. So how would we write the formula, the molecular formula? We would write C5H10. And therein is our molecular formula. Well, how would we write this how would we write the structural form, or the condensed formula? Thank you. How would we write the condensed formula? The condensed formula is going to be written, let's just start it off. So we'll have carbon 1 here. So we'd write CH2. And then next would come CH, because there's only 1 hydrogen attached. The third carbon here is going to be CH again, right? And then it really doesn't matter. That's going to be a CH3. And then again attached to that would be a CH3. Now, when we draw it this way, we don't get the whole picture because you can't really see where everything's attached. Seeing as there's 2 CH3s here, they're both going to have to be on the outside, all right, which gives us a clue of where it's going to be attached, all right? And that would be our condensed formula. So let's move on. Now, for this last example, which we're going to be practicing solving, because we have to be able to go from lines to skeletals to molecular. So on this last example, I've given you the structural formula for it. Okay, so you can see how this whole thing is written out. And I want the molecular formula and the skeletal structure. So let's very quickly just go through and let's find the molecular formula. So to find a molecular formula, which is like H2O or whatever. So how many carbons do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 carbons. And then how many hydrogens? 3, 4, 5, 6, 7, 8, 10, 12, 13, 14, 15, 16, 19, 21, 24. We have 24 hydrogens. And then we have 1 oxygen. So to write that out, we would write CHO would be the order, carbon, and then always have the hydrogen next to the carbon, and then everything else. So it's going to be C13, H24O, because there's only one, so you don't have to put O1. This would be our molecular formula. And now we want to write the skeletal structure. So I've already labeled these carbons, 1, 2, 3, 4, 5. And this is going to be coming off of this third. There's a branch coming off the third. So we'll call that like 3A, 3B, and 3C. Then we can call this one 4A and 4B. And I'm just making it up so we can follow. This would be 4C. And then we might as well make a 4D and a 4E. If we wanted to, we could change it and make it whatever naming we want. But let's start off. Now remember, when we drew our skeletal formula, we learned last time that each carbon is signified by the end of a line or a corner. And I said, hey, draw dots. And if you want to, you can start off drawing dots. So I'm just going to draw my first carbon. So I'm just take a look here, make sure I have room. I think I have room right here. So we'll take this first carbon, and it's going to be right here. And I'm going to go down, and this is going to be carbon 1 and carbon 2. All right. So how many carbons do I have when I draw just one line? All right. So this is carbon 1 and carbon 2. So I'll draw a little 1 and a 2 so we can keep track. And then we have carbon 3, and right up there is going to be carbon 3. And then coming down here, I'm going to have carbon 4. Okay. I have carbon 4. And then I have carbon 5 right over here. So it's going to be carbon 4. And this is going to be carbon 5. All right. So we have our carbon chain set. So we have these 5 carbons right here. All right. Remember, we don't draw our H's. Now, after that, you can look and say, okay, well, what's coming off? Well, we have a 3 carbon chain coming off of the third carbon. So coming off the third carbon, we want to have a 3 carbon chain. So I might have, there's 1, and then remember, we always want to make an angle, and then 2, and then 3. And this would be carbon A, carbon B, and carbon C. I don't have to leave that there. I'm just drawing that for you. So now we have carbon A, B, and C. So we have those 3 carbons. Then coming off of carbon 4, this one gets a little bit dicey. So let's see if we can draw this up. And you can put your angles in different places. But we come down, and we have 1, 2 carbons for sure coming down. So we're going to draw 1, and then I could draw it right or left. It doesn't matter. I'm going to choose to draw it that way. So then I have 2 carbons coming down. And then coming off of this carbon, because this would be carbon 4A and 4B, coming off of carbon 4B, I split again. So I'm going to have to split in 2 different directions. So this one, I'll call this one, I'll put this one up in this direction. So then we'd have carbon 4C there, right? And then coming off of this second carbon, which would be right here, I have a 2 carbon chain, which would be 1 coming down. Looks like my dog is scratching on the door. And then another one, that would be the last one. So this would be D, and then this would be E coming down here, right? So this drawing right here, oops, almost forgot. I almost finished. This drawing here, I need to put this oxygen on. All right. Hey, Munchkin, come here. Come here, kiddo. I'm gonna put this oxygen right up here. My little Munchkin, come here. There we go. Let's get you up here. All right. Say hi to the pumpkins. Oh, look at this little guy. What's up? Look at you just like, Dad, let me out of the room. Well, so suffice to say, kids, at this juncture, this would be the skeletal structure for this compound over here. So we drew the molecular formula and this skeletal structure. So our activity today is going to be going from a molecular form. Well, I won't ever take you from molecular because you won't know where to go. Coming from a skeletal formula and moving into other, here you go, moving into drawing other types of diagrams, and then coming from a line diagram and making a condensed formula, or the condensed formula and making a structural formula. So what you're going to do is you'll be moving between these, okay? All right, now the Lewis dot's pretty much structural formula. So you'll be moving between the structural formula, the line diagram, condensed formula, and molecular formula back and forth. These are pretty straightforward. Structural formula, maybe, and condensed formula, maybe you guys confuse molecular formula and a skeletal. Um, you'll be fine. But I'm really going to be working with these two today, where you're going to be working with a condensed formula and the skeletal formula. Okay. I'll always give you a structural formula. So if you have any questions, just let me know. I'm sitting right here. Um, and that's it. Hopefully you guys are doing well on this organic chemistry. You're really going to want to focus on it because we're going to start getting into some really big compounds. And this is going to lead to some breakouts in learning about some chemistry and some biochemistry and how our body relates to lots of stuff. So that's it. Hopefully you guys have a good day, and I will see you soon.